common form of hydrogen has a bare proton as its nucleus. There can be different kinds, or isotopes of hydrogen, however, because there can be different numbers of neutrons in the nucleus. An isotope is a form of an element having a particular number of neutrons in the nuclei of its atoms. In one isotope of hydrogen, the nucleus consists of a single proton. In a second isotope of hydrogen, the proton is accompanied by a neutron. In a third isotope of hydrogen, there are two neutrons. All the isotopes of hydrogen are chemically identical. The orbital electrons are affected only by the positive charge of the nucleus. We distinguish between the different isotopes of hydrogen with the following symbols. The lower number in each notation is the atomic number, or the number of protons. The upper number is the atomic mass number, or the total number of nucleons in the nucleus. The common isotope of hydrogen, hydrogen-1, is a stable element. The isotope hydrogen-2, called deuterium, is also stable. The triple-weight hydrogen isotope, hydrogen-3, called tritium, however, is unstable and undergoes beta decay. This is the radioactive isotope of hydrogen. The three isotopes of hydrogen have different numbers of neutrons in the nucleus. The varying number of neutrons changes the mass of the atom, but not its chemical properties. The common isotope of uranium is uranium-238, or U-238 for short. It has 92 protons and 146 neutrons in its nucleus. It's radioactive, with a smaller decay rate than uranium-235, or U-235, which has 92 protons and 143 neutrons in its nucleus. Any nucleus with 92 protons is uranium, by definition. Nuclei with 92 protons but different numbers of neutrons are simply different isotopes of uranium. All isotopes of uranium are unstable and undergo radioactive decay. Since some radioactive nuclei are more stable than others, they decay at different rates. A relatively stable isotope will decay slowly, while an unstable isotope will decay in a shorter period of time. The radioactive decay rate is measured in terms of a characteristic time, the half-life. The half-life of a radioactive material is the time needed for half the radioactive atoms to decay. Radium-226, for example, has a half-life of 1,620 years. This means that half of any given specimen of Ra-226 will have undergone decay by the end of 1,620 years. In the next 1,620 years, half of the remaining radium decays, leaving only 1/4 the original number of radium atoms. After 20 half-lives, an initial quantity of radioactive atoms will be diminished to about 1/1,000,000th the original quantity. Each isotope of a radioactive element has its own characteristic half-life. Rates of radioactive decay appear to be absolutely constant, unaffected by any external conditions. High or low pressures, high or low temperatures, strong magnetic or electric fields, and even violent chemical reactions have no detectable effect on the rate of decay of an element. Any of these stresses, however severe by ordinary standards, is far too mild to affect the nucleus deep in the interior of the atom.